Hi everyone, I am Gautam, I am physics faculty. Now I am going to discuss a problem on expansions of solids. Now here you can observe the question here, that is a hole of 4 centimeter in diameter is made in a brass plate at a temperature of 20 degrees centigrade. That means they have taken one brass plate here. Inside this brass plate, what happened means they made one hole. That whole diameter D1, let me call it as D1, they have given it as 4 centimeter, and the temperature here is 20 degrees centigrade. After that, they told that in the question, if you observe, the diameter of the hole when the temperature of plate is increased to 100 degrees centigrade. The diameter of the hole when temperature of plate is increased to 100 degrees centigrade. If temperature increases, automatically it will expand. So the hole diameter also increases. Let me take the hole diameter. Now it becomes D2. They are asking what is this D2 value. Now the temperature, they told it is 100 degrees centigrade. As the temperature increased, it is expands, no doubt. Okay, fine. So this is the given, and the question you can also observe, they have given coefficient of linear expansion 20 into 10 power minus 6 per degree centigrade. Here D1 is diameter 4 centimeters at T1 20 degrees centigrade. D2 is how much? Diameter, how much it becomes when temperature is 100 degrees centigrade. This is a simple question they asked us to find. So how to solve this question means, now what I am doing, just I am taking first the total data I am writing now. Observe carefully here. I am taking the data alpha is equal to 20 into 10 power minus 6 per degree centigrade, and initial diameter 4 centimeter when the initial temperature is given as 20 degrees centigrade. Then the final diameter D2 is equal to how much when temperature is 100 degrees centigrade. Here what I noticed, T1 20, T2 100 like that. Then my formula which suits for this one is alpha is equal to, because alpha is what? Coefficient of linear expansion. Here D1, D2 are diameters. They are also linear. Diameter means linear only, no beta. Radius, diameter, length, all are related to linear. So now I can write the formula as alpha is equal to D2 minus D1 by D1 T2 minus D2 T1. This is the given formula. When we are selecting this formula means generally we will be selecting this formula if at all D1 is given, D1 is length or diameter or radius at T1 degrees centigrade, and D2 is given at T2 degrees centigrade, they are given. Then we can take the alpha coefficient of linear expansion formula as D2 minus D1 by D1 T2 minus D2 T1. This D can be diameter or length, or it can be radius, anything. So they are given two unknown temperature, that means 20 degrees, 20 degrees centigrade, other one is 100 degrees centigrade. So we can use this formula. If at all they didn't mention like that, simply temperature difference they have given, temperature difference. Then what you have to write, the alpha is equal to D dash minus D by D into delta T. This formula, simply temperature difference they mentioned. They didn't give the proper data, then we'll take alpha equal to D dash by D into delta T. No, here they didn't mention temperature difference like that. They told T1 value, T2 value clearly they mentioned like this. Then you have to use this formula D2 minus T1 by D1 T2 minus D2 T1. Simply they told increase it by 20 degrees or decrease it by 20 degrees. Then we have to use here delta T. It is convenient way to solve the problem. Now in this formula, now I selected this formula alpha equal D2 minus D1 by D1 T2 minus D2 T1. Just substitute D1 value here. and G2 we have to find. T1 is given, T2 is given, alpha is given. If you substitute and solve, you will get the answer. You will get the answer for this question. I hope you understood how to handle this question now. So, similar model sum we will see here related to the diameter, that is here the inner diameter of brass ring at 273 Kelvin is 5 centimeter. They mentioned inner diameter of brass ring at 273 Kelvin is 5 centimeter. To what temperature should it be heated for it to accommodate a ball of 5.01 centimeter in diameter? So, what happened here? They are having one brass ring. They are having one brass ring. Along with brass ring, they also have to what they want to accommodate. They accommodate a ball of 5.01 centimeter. That means compared to the ring size, the ball size is big. The ball size is big. So the ball diameter is how much? 5.01 centimeter is the ball diameter. But our diameter of this ring is how much? Simply 5 centimeter. Now I want to insert this ball into this ring. That means the ring must expand. So how to insert the more diameter one inside the ring means? No doubt. Observe carefully, but a very simple logic. This the ball is there. This ball is having 5.01 centimeter diameter. We have to insert this ball into this ring means the ring must expand or not. Without expansion of ring we can't insert. So we have to heat the ring such that this ring expands to diameter to 5.01 centimeter. Suppose this ring diameter also now increase it to 5.01 centimeters. Then we can fit this ball inside the ring. We can fit this ball inside the ring. Because ring diameter is less than ball diameter, ball to be fitted in the ring means definitely the ball must expand. To what level it has to expand? It has to fit means to the equal to the radius of ball. That means diameter of the ring must increase to equal to the diameter of the ball. So I hope you are clear what the question is given. Now let us write the data here. Alpha is equal to 2 into 10 power minus 5 per degree centigrade. And temperature, initial temperature is given as, let me take in Kelvin, no problem, 273 Kelvin. T1 is 273 Kelvin. Initial diameter is 5 centimeters. And final diameter is 5.01 centimeter. If we increase the diameter to 5.01 centimeter, then we can accommodate that ball. So we are increasing the diameter of the ring to 5.01 centimeter. Why 5.01 centimeter? Because ball diameter is 5.01 centimeter. Ball diameter is 5.01 centimeter. So we are increasing the ring diameter also to 5.01 centimeter. So now what is the temperature to be heated to happen this phenomena? What is the temperature required? What is my formula for alpha means? Simply I can write here alpha is equal to d2 minus d1 by d1 t2 minus d2 t1. Remember, this is the formula for coefficient of linear expansion. And one more information. Sir, we are taking here Kelvin. So options are also given in Kelvin. Options are given in Kelvin. This initial temperature also given Kelvin. But alpha we took per degree centigrade. Alpha we can either write per degree centigrade or Kelvin. Both are same. For alpha per degree centigrade Kelvin. Because in the denominator we will be having different temperature difference. So per degree centigrade or per Kelvin, both are same for alpha. So let us substitute the data here now. So alpha is 2 into 10 power minus 5. 5.01 minus 5 by D1 is how much? 5. T2 is how much? We have to find. And D2 is how much? 5.01 into 5.01 into what is T1? T1 is 273. If you simplify this one, you will get the value of T2. You will get the value of T2. This is how to solve this type of related diameter sum. I hope you are clear now how to handle. What I did here, I took alpha T1, D1, D2 and T2. D1, D2 are diameters. So, where the alpha formula, what is alpha formula when diameters are given? D2 minus D1 by D1 T2 minus D2 T1. By applying this formula, we can solve this problem in this way, and finally we will get the value of T2. We will get the value of T2 in what units will get? Kelvin. You will get in Kelvin because everything we have taken in Kelvin. So remember, alpha per degree centigrade or per Kelvin is same for alpha. So that is the information related to this problem. I hope you are clear with this one. Now see this question. To understand more better, you observe this one carefully here. A brass disc fits in a hole of a steel plate. Now the problem is, read the question properly. A brass disc fits simply in a hole of a steel plate. Brass disc is fitting in a hole of steel plate. Okay. So now this is some steel plate. We'll think this is some steel plate. At the steel plate center, what happened means hole is there. Let us think this is the hole of the steel plate. And inside this hole, what is there? Inside the hole of the steel plate, what is there? Brass disc is there. Inside the hole, what is there? Brass disc. So here we are having inside what is there? Brass disc is there. Let us concentrate the data here. This is what? Steel plate. And inside what we have? Brass disc. Like that it is fitted inside. And happily they are staying like that. So that is the question. See here, a brass disc fits simply in a hole of a glass plate. Okay, we understood that one. What is the question they are asking? The disc from the hole can be loosened if the system. So our target is to remove the brass disc. So what should we do to remove brass disc from steel plate? Two cases we'll observe. Suppose if you heat, what will happen? If you cool, what will happen? We'll check. If you heat, what will happen? If you cool, what will happen? If you heat and cool the total system, First of all, one thing you have to know. One secret is there here. What is the information related to alpha of brass and copper steel means? Alpha of brass is greater than alpha of steel. This information we have to know better. Without knowing this information, we can't solve this problem. So alpha of brass is greater than alpha of steel. That means brass alpha is greater than brass or steel alpha means it says that when heated, brass expands more than steel. When heated, brass expands more than steel. When cools, brass contracts more than steel. Brass contracts more than steel. So, if it is heated, brass expands more than steel. If it is cooled, brass contracts more. So, now the question is either we have to heat or cool. What is the answer? Yes, observe carefully here. If we are heating, suppose, brass what will happen beta? Expands more than steel. Brass is expanding more than steel means it will expand. So it is expanding means in this way, can it come out? It will fit more tight it becomes more tight if it expands like that. Inside brass expands means, because compared to steel, brass is expanding more. We can't remove it, it will become more tight. But if you cool beta, what will happen? Brass contracts. Brass contracts more than steel. Compared to steel, it contracts more and easily we can remove it. So for this question, what is the answer we can say here is, that is, the whenever the disc is heated, what will happen? As brass expands more than steel, and brass is inside the steel, it will become more tight it becomes. If it is cooled, what will happen? Brass contracts more than steel, compared to steel, it contracts more, so that it is easily removed, we can remove. Why? Because brass lies inside the steel. This one inside one is brass and outer one is steel. So it lies inside. It has to be cooled. Now our answer is, it has to be cooled to remove brass from the steel plate. It has to be cooled. If heated, we can never remove. It will become more tight inside, more fits here, and we can't remove. So our answer for this question is, by cooling we can remove the brass. Suppose, for example, the question is reverse. We'll think the reverse question. What is reverse question, sir? Suppose the outer one is brass, inner one is now steel, is there inside. Now alpha of brass is greater than alpha of steel. So how to remove this one? If we heat, brass expands more compared to steel. Brass expands more than steel. Because alpha of brass is greater than alpha of steel, brass expands more than steel, and we can remove steel. Easily. So it is cooled, it can't happen. It cooled means brass contacts more than steel and become more tight. We can't remove. So reverse question. Suppose outer one is brass and inner one is steel. What we have to do? Heating. Inner one is brass. Suppose inner one, what we took according to the question, inner one is brass, outer one is steel. Then what we have to do? Then we have to do cooling. To remove brass from steel. This phenomena you have to be very clear, and it's a very important logical topic here. And you have to know which is greater. Without this information, you can't find this one. Remember always, brass alpha is greater than steel alpha. I hope you are clear with these questions. Totally 3 diameter questions we discussed. First one, hole diameter is increasing, that concept. Second one, from that is a brass ring is there, we have to fit the ball inside the ring. For that, diameter of brass ring must be increased. So third one, we discussed, when brass is inside the steel plate, to remove we have to do cooling. Like that, we discussed today problems related to these expansions of solids in thermal properties of matter chapter. I hope you are clear with these problems. Thank you.